We are going to get started with day 14. All right. Day 14, extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine. And the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules for a puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. The first line is the polymer template. This is the starting point of the process. So in this case, it's NNCB. The first line is the polymer. The following section defines the pair insertion rules. A rule like AB, arrow C, means that when elements A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. Let's see. So starting with the polymer template NNCB, the first step simultaneously considers all three pairs. The first pair, NN, matches the rule NN to C. So element C. One second. Let's see. Okay, so NC, so element C is inserted between the first N and the second N. The second pair, NC, matches the rule NC to B. So element B is inserted between the N and the C. The third pair, CB, matches the rule CB to H. So element H is inserted between the C and a B. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. After the first step of this process, the polymer becomes NCNBCHB. Here are the results of a few steps using the above rules. This polymer grows quickly. After step 5, it has length 97. After step 10, it has length 3073. After step 10, B occurs 1,749 times, C occurs 298 times, H occurs 161 times, and N occurs 865 times. Taking the quantity of the most common element, B, 1,749, and subtracting the quantity of the least common element, H, which is 161, produces 1,588. Apply 10 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay. So we're going to split by 2 new lines. And this is going to be start and then insertions or whatever. And then insertions will be insertions dot split lines. Let me make this a little bit bigger for you guys. All right. And start should be good, I think. print start and insertions. Needs to be updated before I can run it. Huh? So we've got NNCB, and then we've got the different insertions. Okay, so this is going to be a list. It's going to have yeah, it will just be I.split for I and insertions dot split lines. So let's check, see what that is. I want to split by the arrows. And so we've got that. So let's check it. And then I might as well just add the spaces after it. So now we've got everything split up. So what I'm going to do now is, so start is our, start list, but I'm going to go through, I'm wondering if making, let's see, so CH, HHTB, NH, HB, HC, and HN, NNBH, NC, NB, BN, BB, BC, CC, CN. So the last will always be B. The first will always be N. So in this case it was NN, so I'm going to insert C. And then there's NC. Let's see. So, let's see. Less than 10, yeah. Then we will. So we need to have two things. We need to have. No, that's fine. So we have our start. Oh yeah, so it's for insertion. Okay, so because I'll have the search for each of them. I should make it a set, so I should split them up. I made a dictionary actually, but. So let's see. Honestly, I don't really use this, so we'll try it. Okay, so it's too dict then. Is it just a standalone thing? Okay, so let's look it up real quick. thought it was a... iterate. No, I don't. Honestly, I'm not sure what iter does exactly. So we've got a dictionary that holds all these things. So instead of having to search through it, we just, have it once. So we've got our steps, and then so I need to have two strings or lists. Okay, and then length of previous. We'll just do the previous string. We're looking at the previous two. So we're looking at so next string plus equals previous string position -1, and then it adds on the insertions, and we're looking at the previous string position -1 to the position +1. So there's, let's see, so there's 4 at first, and then CB. So we go through starting at 1, 2, 3. Yeah, okay, we're good. And before we do, so we stop at 3, but we're checking 2 to 4. Oops, sorry. And then 3073. Oh, and then we're doing the least common element as well. So we need to count each of the letters. So I need to split them up, right? So we'll just make accounts, dictionary, for char and next string. If char not in counts, counts char equals 1. Counts at char plus equals 1. And then what we're going to do is max count equals, well, let's just do counts. Oh, no, I'm good. So I'm printing the max of counts dot values minus the min of counts dot values. Okay. So let's switch this over to input. So let's see. All right, part 1 is done. And okay, the resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process. A total of 40 steps should do it. In the above example, the most common element is B, and the least common element is H. Apply 40 steps of pair insertion to the polymer template and find the most and least common elements in the result. What do you get if you take the quantity of the most common element and the least common? Okay, so it's just more steps. All right, so I had to kind of restart and rethink how I did part 2 because it would take way too long to do 40 steps. It would take a lot of memory and just resources. So I got a tip. It's more than just a tip, but they helped me out a lot in understanding what it is I need to do. So I've redone this, the file or whatever, just so I can get the part 2 done. So let me just copy over my puzzle input real quick. And then the example. Okay, so what I have is I'm going to read in the lines. The lines are actually going to split by 2 new lines. And then I'm going to do start is going to be lines 0. And then insertions is going to be lines 1 dot split lines. But it's actually going to be more than that. It's going to be a list of the so left and right pairs for L. I actually just need to do line dot split. I did this before, so I'll skip past it. It's a space and an arrow for line in lines 1 dot split lines. So then I'll print the insertions. Okay, awesome. So now what I do is I have my counts is a dictionary, and then what I do is I go through and I will so for what do you call it? I in insertion. Oh, or actually I should go through the characters. So for position for position. Oh man. Okay. Yeah, make it a little bit bigger. Okay. What I'm going to do is for position and range 0. I don't need the 0. Length of insertions -1. Then I do I'm going to look at the characters, or so the counts. Okay, so the reason I would use a counter is because it increases by 1 each time anyways. So I'm going to make this a counter. It's a counting dictionary, so it's in the collections. I believe it's collections. Yes. So I've got a counter here. So now what I do is I do counts. Oh, okay. So I need to have the let's see. So then I have I'm going to check. Let's see. Counts as the counter. I'll need 2 counters. Position in range. That's fine. I need a new counter, so let's see. So I need to look at... So I'm just getting the counts. Let's see. And adding it to the next counter. So, NCNBCHB. So I'm going to go through this string. Technically, I'll go through the counter. So I should go through the counter once before. So let me do that. For position, so previous counter, what do you call it? Insertions, position -1, position +1. Or no, in this case, it's going to be position +2. Plus equals 1. So then, okay. Then I go through the steps, and so I've got a next counter. And then for what do you call it? I'm going through the previous counter for counter and previous counter. I just want to see what it looks like. Because it's not insertions. It needs to be a dictionary. So this will be okay. I think that should be good. Wait, previous counter insertions. Oh, because I don't want the actual insertion. I want the... And we're not doing length of insertions. We're doing the length of start. And we're looking at start position. Okay. Okay, so we've got CB, NC, and NN. Okay. So then for counter and previous counter, we are going to, so next counter, so I'm looking at the, what NN creates. So this will be next counter, insertions, counter, insertions counter 0. Okay, so I need to get the count. Let's see, the letter. So if I'm looking at NN, then I need to add NC and then CN. So what's NN? So for counter and previous counter, because this counter is going to see this, and then the next counter needs to have the first letter plus what they would create. So middle equals, let's see, insertions, counter. And so print insertion, or print middle. So we've got H, B, and C. Okay, it's good. HBC. So then what I need to do is LR equals counter dot split. No, it's just a list. Counter. And then I'll print LNR just to see if it's working. Okay, CB, NC, and NN. Okay, looks good. Okay, so we've got a list counter. So then what I'm going to do is next counter. So I need to count the number of times the counter is seen in or false. No, wait. So LR middle. So the next counter left and middle plus equals 1 times what the previous counter is. So next counter counters, we join it, it's going to equal the previous counter plus equals 1 times the previous counter times the previous. Okay. Previous counter, right? Next counter, previous counter, and then The next counter is middle and right times the previous counter. So there's one CH, one CN, one BC, one NB, one NC, one HB. So let's do 10. And then afterwards we will print. This is 812 BBs. 796 NBs. And then most common is a method that orders them. And so then I can do previous counter. Let's see if this works. And no, because that's doing a index, whatever. Let's look at Python counter. So elements, most common. Okay. And least common elements. So let's see. Previous counter. Is this going to give the least common then? Okay, so that's the most and that's the least. But that's not the letters. That's just the... So what I need to do is for key value in previous counter.items. For letter and key, letter counts, letter. I guess I can just make this another counter because then I don't have to worry about plus equals value. Letter and key, letter counts, letter plus equals value. Okay. BNCH. There's only B, N, C, and H. Well, that makes me feel a little bit better. So there are a total of, or it's a total length of 3,073. Which is definitely more than so let's see. I don't think that makes a difference. Nope. Cool. So when I go to the next step, there'll be NC, CN, and NCB. So there's one NC and one CB. But if I count them up, that's going to be a total of one, two, three, 4, 5, 6. That's going to give me a total of 6. If I only count the left one, then it's not going to give me. NNCB. NCB, NCN, BCHB. So loud. How do I count them so I don't overcount them? If I did 9, what does it give? How does it go? Dot total. What? You telling me that I'm wrong? Letter counts is a counter. It says it can do total. Let's see if it tells me that this is wrong too. 3072. But in this case, there's 3073. There's 1,749, 1749, and 161. Clearly, it's not correct. But I'm on the right track. is going to give me one NC and one CN. But it doesn't count both of them. One NC, one CN. What's the total number? Two, 1, 9, 4. Clearly. Oh, because it's the... most times the least. Okay, so NNCB. I'll put some music in mine, but says once. So CH, CN, BC, NB, NC, and HB. NCN, BC, HB. 1, 2, 3. So there's 2 N's, but this counts as 3. So should I take the count that I see and then subtract it by 1? After each time? So go out there, there's 1 NN, so I add NC once and CN once. So NC does NB and BC once. Doesn't change it at all, does it? There's a length of 3073. So I go through each counter, the previous counter. So then there are two BBs, two BCs, two CBs, two NBs, one CN, one CC, one BH, one HC. One, two, three, four. So what's happening is do I like go through the last one and not subtract one? I subtract maybe the number of times. Is it during or after? It's one step, two steps, so after step 5, after step 10. So it happens 10 times. This is the 10th, after the 10th time. This is has length 3,000. So I think I do need to go through and divide it by 2 and subtract 1, I think. Okay, so we're printing the previous counter, the letter counts. So after the first one, it should be, there's 2, B is 2, N is 2, and H is 1. So it should int it and then divide by 2. Or divide by 2 and then add 1. One, 2, 3, 4, 5, 6. Int. So to divide by divide by 2, and then add 1. So what I'll do is why is it giving a value of 9 now? So I floor divide by 2. And add 1. So this would be 1. So it's 2. Or this should be 2. Why is it showing 3? 1, 2, 3, 4. Or maybe if it's odd. Seven, 13, 25, 49, 97. Okay, I think I did it. I have to add 1 and divide by 2. Because it's 1 less than. Okay, so then let's change this back to input. 2195. $15.88. Huh. KS appears 1,003 times. Or maybe this one it's only doubles. Left, right, double. Or maybe when it's doubles, I only add one instead of both of them. Oops. This is the same thing, isn't it? Because if it's odd, that's going to be the even. What is it that I'm missing? NC and BCHB. Two 188 189 693 529. Huh. Too high. I could check if it's too high by 1. So we'll wait, a few seconds.
problem. That gives me the correct answer, but when I do input, it gives me one higher. On this problem or the 12 problem? Day 14. Oh, sorry, yeah. What was there on to that one that had it off by 1? Did I have that issue as well? Off by 1. Okay, so if you're... Are you keeping a count of all the pairs? So how often each pair happens after the iteration, yeah? And then how do you count the appearance of each letter? So I think what I did was I counted the first letter against the count against the pair, and then I just had to add that last letter once. So we'll go back to code that. 14 part 2. I count each letter and then divide by 2. Okay, I think... will that work? Will that work? Will that work? I'm not sure that will work. Or I'm not 100% sure I can phrase why it wouldn't. But what I did was I counted... Yeah. So I went through the pairs and the counters, and I added the count for the first letter in the pair only, and then I went to the next pair and I counted the first letter, counted the first letter, counted the first letter, and then that leaves me over with the very last character, which doesn't get counted. So that was just a +1 at that point. It might actually be as easy as if you count them with the pairs divided by 2 and you have to add 1. That might actually be the reason, because with all the pairs, 14 sample. So in the case of the NNCB, we have NN, NC, and CB. And in this case, it would be 1, 1, 1. So if you count how many N's there are, there's 2, 3. And if you count how many, sorry, let's do that again. Count how many N's there are, then you get 3. If you count how many C's there are, you get 2. And you count how many B's there are, you get 1. So you overcount the first ones, but you count correctly only on the last one. So the last character is a special case in any case. So there's the numbers of N's. So if you do, well, you counted 3 and divided by 2, what would that give you? Give you 1, right? Length of the starting string. Do you reckon it depends on the length of the starting string? Not sure about that. But yeah, I couldn't really say, depending on the algorithm you're using for counting. I think that was one thing that I had something incorrect with, how I was counting them. If I go undo all of that. Oh. 14 part 2. Yeah, so you see here I've got counters commented out and stuff like that. So that was something with the counters that I was off. But I don't think in my case I wasn't off by 1, I was off by a lot. So I rewrote it and got there in the end with this counting only the first character and then first character of every pair, and then at the end just counting that very last character because he would not be the first character of any pair. What were we laughing about? Yeah. It's a little harder to comment on what you might be doing wrong when I don't see it, but hopefully it made some sense. 15 part 2.
So if the starting string starts or is 4,
Yeah, I don't remember. Yeah, that was something with the counts were off, and then when I went through all the trouble
4, 7,
the
13,
counters, as in the pair counters, they were actually correct.
49.
The individual counts for the final solution were way off. So there was something.
97.
I think I tried a couple of things adjusting.
So I guess after that it never
rewrite the counting part.
Twice minus
Anyway,
2.
So
or 1,
or what am I doing? We've got here.
Yeah, it never goes to. Because if you're 20, it's 20, 39,
more than or equal to
77.
Or or x is more than or equal to calls. That should also be fine.
That is interesting.
Then,
oh well.
What is it exactly that I'm doing? I'm not sure if this is right. Let's try it at least. Orig equals grid x.
All right, so there you go, guys.